All right, this is complex numbers part two. Make sure you watch part one before this one. So in part one, we talked about this equation, I is equal to the square root of negative one. In this video, we really focus on this equation, I squared is equal to negative one. So these are two that you kind of have to memorize. But in this video, we're really focusing on this equation. So the warm-up covers what we did in part one. So we'll go through this first. For number one, we have the square root of negative 49. And basically, I can do up here, that means that we need two things that multiply to give us negative 49. That's what this means. And so they have to be the same number with the same sign. So positive 7 times positive 7 gets us positive 49. And negative 7 times negative 7 gets us positive 49. There are no two real numbers that are going to multiply to get us a negative number. And so that's why we need these imaginary numbers to answer questions like this. So what we do when we see a negative under the radical is we're going to rewrite this by pulling out the square root of negative 1. So this is really the square root of negative 1 times the square root of positive 49. And we can do this because if you multiply these back together, negative 1 times positive 49, okay, that gets us the square root of negative 49. And the reason we do this, we want to pull out that square root of negative 1 because this is equal to I. That's what we learned last class. We want to simplify these in terms of I. That's the goal. And then the square root of 49, you could do a factor tree on this one, but this happens to be a perfect square. This is one we have memorized. We know the square root of positive 49 is 7 because 7 times 7 gets us 49. And so we have I times 7, which we generally see written as 7I. For number 2, we have another negative under the radical, so we'll have to do the same process. We'll pull out the square root of negative 1 and multiply it by the square root of positive 78. We do this because we know the square root of negative 1 is equal to I. The square root of 78, that's not one we have memorized. It's not a perfect square, but we can do a factor tree. It's kind of an interesting number here, but it's even, so we know we can, it's divisible by 2. I know 2 is going to be one of the factors, and it's 2 times 39. That gets us to 78. And we can keep breaking down the 39. That's, see, 3 and 13. And interestingly, we can't break down the 13 anymore. We're left with all singles. Remember, we just want to focus on the ones at the ends of the branches, so not the 39. There's no pairs, there's no couples. So what we do is we multiply all the singles together and put it back under the radical. Well, 13 times 3 times 2, that's 78. In other words, we cannot simplify the square root of 78 because there's no pairs. And that's just how it goes with these radicals. If there's no couples, no pairs, they can't be simplified. So we just have to leave it as it is. And then last, I'll bring down that I, put it out front. And so this will be our answer. For number 3, we have a coefficient out in front, the 2, but it doesn't change things a whole lot. We're just going to multiply it in. So I'll put the 2 out front, but we're still going to have to pull out that negative 1. So this is the square root of negative 1 times the square root of positive 140. So this is just something we have to do when we have that negative under the radical. And that's because we just want to pull out that I. We want to leave this in terms of I. So now I have to simplify the square root of 140. It's a pretty big number, but let's see, 14 times 10 will get me 140. You could have used 2 and 70 or 20 and 7, but 14 and 10 works. We can split that into 7 and 2, and this into 2 and 5. So we have a pair of 2s and 2 singles. Remember, I don't care about the 14 and the 10 anymore because they're not at the ends of the branches. So we say couples go out and singles stay in. So my couple of 2s goes out. And then we have 2 singles. So in that we have 2 singles, we're going to multiply them together. So 7 times 5 gets us 35. Singles go in. It's not my final answer though, because I still need to bring down my I, and I still need to bring down my 2. And so now we can clean this up by doing 2 times 2, which is 4. Attach my I, and then attach my square root of 35. So that would be the final answer. Notice I didn't do 2 times 35. We can't multiply an outside number with an inside number. That's not allowed. So I can only multiply these outside pieces. So that's what we did in part 1. Now we're really going to focus on I squared being equal to -1. I'll fill that in a bit. So we also added and subtracted in part 1. Part 2, we're going to multiply. So this part right here, I'm going to go through, and what I said in class is this first column should make sense to everyone. This second column, it's good to understand it, but it's not super necessary, I would say, to complete these problems down here. It's just to have a better understanding of these imaginary numbers. So this first one, we have I to the 0. And we don't have to know anything about imaginary numbers to answer this. Anything to the 0 power is always going to be 1. Okay. For this next one, we have I to the 1st. Well, anything to the 1st power is just equal to itself. 2 to the 1st power is 2. 3 to the 1st power is 3. I to the 1st power, it's going to be I. I squared, that's the one that we are going to memorize today. That one is equal to -1. That's the one we're going to use a lot down below. So these are the important ones, but over here we can derive these. We can figure these out based on this first column. So I to the 3rd, well, that's really the same thing as I to the 2nd times I to the 1st. I know this works because if I'm multiplying with the same base, I can add my exponents. 2 plus 1 gives me that 3. I could have put the 1 here and the 2 here on the exponents. It doesn't matter. All right, and then I squared, well, we know that's equal to -1. And then I to the 1st, we know that's equal to I. -1 times positive I gives us a -I. So we know I to the 3rd is equal to -I. And so that's what we're going to do for these others. I to the 4th, okay, we can use exponents of 2 and 2, that equals 4, or 1 and 3, 3 and 1, doesn't matter. I'll use I squared times I squared. Again, that works because if we're multiplying with the same base, we just add our exponents. Okay, and again, I squared we said is equal to -1. So this is the same thing as -1 times -1. And that is equal to a +1. And we'll go ahead and just do it one more time here. I to the 5th, okay, we could use exponents of 3 and 2, 2 and 3, 1 and 4, 4 and 1. It doesn't matter. I'll use 3 and 2. Okay, so I to the 3rd, well, we just found that up here. We said that's equal to -I. And I to the 2nd, it's the one we're memorizing, that's -1. And -I times -1 is +I. And so there is sort of a pattern to this. If you look back here, we have 1i, negative 1, negative I. 1i. Well, if we were to find I to the 6th power, it's going to give us negative 1. And if we were to find I to the 7th power, it's going to give us negative I. It just follows a pattern. 1i, negative 1, negative I. 1i, negative 1, negative I. 1i, negative 1, negative I. So that's just an interesting fact about these imaginary numbers. So really we could simplify very big exponents if we wanted to. We won't be doing that, but that's something we're able to do just knowing about this pattern. We're really just kind of going to go up to I to the 2nd, maybe I to the 3rd. But once we have these, we can figure out any of them. Okay, so for number 1, we're going to go ahead and multiply now. We have 2i times 3i. So I'm going to start by multiplying my coefficients. 2 times 3 is equal to 6. And we have I times I. Remember, this is really I to the 1st times I to the 1st. If I'm multiplying with the same base, I add my exponent. So this is I to the 2nd. And so from now on, we don't want to leave this as I to the 2nd. We know that I to the 2nd, I squared, that's equal to negative 1. So this is really 6 times negative 1, which is negative 6. So we're trying to simplify these down as much as possible. It's okay if we leave it in terms of I. We don't want to leave an I with an exponent because we know we can simplify those down. For number 2, we have this 5i out in front of some parentheses. We know we have to distribute it, that is multiply it by everything inside. So 5i times 10, that's going to give us 50i. And 5i times 9i is going to give us 45i squared, right? If we're doing an I times an I, that's I to the 2nd power. We don't want to leave it like this. There's a piece we can simplify. This I squared again, we know that's really equal to negative 1. And 45, positive 45 times negative 1, that gives me negative 45. I can bring down my 50i. And so that's our answer. We could leave it like this, but generally with complex numbers, we see the real number first and then the imaginary number. So I'm going to take this negative 45 and put it out front, and this positive 50i, I'll put that last. So that's generally how we see it. For answer choices, it's going to look like this with the real number first and the imaginary number. That is just how mathematicians do it. For number 3, we're going to go ahead and distribute that I again. So I times 6 gets us 6i. I times negative 5i, that's negative 5i squared. Again, we know I squared is just equal to negative 1. So we have negative 5 times negative 1, that's a positive 5. I'll bring down my 6i. And then again, finally, we want to flip these because we want our real number, the 5, first, and then our imaginary number, the 6i, second. Okay, so let's move into the more challenging ones. So 4 should look a little bit similar. We've done problems that sort of look like this, where we have 2 terms times 2 terms. It's a binomial times a binomial. We could FOIL, use the FOIL method, or we could use the box method. So this is something we did in the first month of school, except instead of i's, we had x's. So my first expression, 4 plus I, I'll put down the side. My second expression, 4 minus I can put up here. All right, and so to fill in the box, we are doing multiplication. So for this first box, I'm doing 4 times 4. That's 16. For this box, I'm doing 4 times negative I. That's negative 4I. Here I'm doing I times 4. That's 4I. This last box is always the trickiest. In this case, let's see, we have I times negative I. Well, a positive times a negative is a negative, and I times I is I squared. So from here, we're just going to add up our boxes. So I'm just going to list it out here. Start with 16. And I have minus 4I plus 4I minus I squared. And so there's a couple things we can do to clean this up a bit. First of all, I see these like terms, negative 4I plus 4I. Well, if we have 4 apples and we take away 4 apples, that's just 0. These cancel right out to 0. So bring down my 16. And then right here, I squared, we know is equal to negative 1. But this is really a negative times a negative. It's like there's a 1 in front of the I. So you can think of this as negative 1 times negative 1. That gives us a positive 1. That's a little bit tricky there. So you may need to revisit that. But it's a negative, negative 1. So it makes it a positive 1. And then this, 16 plus 1, that's just 17. And 17, that's a whole lot simpler than what we started with all of these i's. Okay, so for 5 and 6, we're doing the same thing. Some people like to FOIL. Maybe I'll FOIL number 6, but I'm going to do the box method again for this one. So we have 2 minus 3i. I'm going to write that down the side. And then 9 plus 10i, I'll put up here. So again, we want to fill in the box by multiplying. So here we have 2 times 9, gives us 18. Here we have 2 times 10i, that's 20i. Here we have negative 3i times 9, that's negative 27i. And this last one's tricky. We have negative 3i times 10i. That's negative 30i squared. So now I'll just add up all of my boxes. I'm going to list them out right here. So we have 18 plus 20i minus 27i minus 30i squared. So a few things we can do. I got some like terms. 20i minus 27i, that's equal to negative 7i. Can bring down my 18. And now I'm going to deal with this I squared. I know I squared is equal to negative 1. And again, we have, okay, it's a negative times a negative. This is negative 30 times negative 1. That's positive 30. And so then we can combine the like terms here. 18 plus 30, that's 48. And I'll bring down my minus 7i. Notice I have my real number first and then my imaginary number. So that's our answer. For this last one, I'm going to go ahead and FOIL it if you like foiling better. That stands for first, outer, inner, last. So my first terms are the 6 and the 1. Those are the first terms in each expression. 6 times 1 is 6. O stands for outer, so that's 6 times 8i. That's 48i. I stands for inner. That's negative I times 1, which is negative I. Same thing as negative 1i, by the way. And then L stands for last. That's negative I times 8i. So that's negative 8i squared. So we'll combine these like terms. 48i minus 1i is 47i. I'll bring down my 6, my plus sign. Over here, that's going to cancel to negative 1. Negative 8 times negative 1 is positive 8. So then I can combine these like terms right here. So my final answer is 14 plus 47i.